Assalamualaikum and hi everyone. So today we are back to continue our lesson for our last subtopic, which is entitled optimization problems. Optimization are very important at almost any other field like engineering, physics and also business too. For example, when someone consider a business strategy in minimize costs or maximize profits. When we said about optimization, it always related to maximum and minimum values. And it is something that we have learned how to do. At the end of this lesson, you should be able to apply the differentiation technique to the optimization problems. So let's go for the introduction first. What is optimization? Optimization is the process of finding maximum and minimum values. So we are basically looking for the largest value or the smallest value. So how to determine the function whether it is a maximum or minimums? It is simply by using the second derivative test. So before we proceed, let's recap back of what we have learned. The second derivative demonstrates whether a point with zero first derivative is a maximum, a minimum, or an inflection point. Basically, for a maximum, the second derivative is negative or less than 0. For a minimum, the second derivative is positive or greater than 0. Let's go for example 1. A closed box is to be rectangular solid with a square base. If the enclosed volume is 32 inch cube, determine the dimensions for which the surface area is minimum. So now let's say this is a rectangular solid with a square base. A square base, we have the same side equal length. So we have x and x side of length. And then the height, let's say for this box is y. So the question actually asks what is the dimension for this kind of value, which is x and y, that can make the area is minimum when the enclosed volume is given as v is equal to 32. Okay, now we need to identify what is the volume and area formula first in order to solve this optimization problem. So to get the volume formula, we know that it's a width times height times length. So we get x multiplied by x multiplied by y. So we get x squared y is equal to 32. So let's make this as one term for to substitute into another formula later. So we get y is equal to 32 over x squared. Okay, what is the area formula here? Okay, the area formula here is actually we need to identify it by looking at the total surface area of the square base and also the rectangle side. Okay, for a square side, we know that is x multiplied by x, so get x squared, and there is a two surfaces of x squared, so we get 2x squared. So how about the rectangle side? So we get actually x multiplied by y. So we have four same side of xy. So we get 4xy. So the total surface area here is actually 4xy plus 2x squared. Okay, so now as we get the formula of area, now we substitute back the y is equal to 32 over x squared into the a formula. So we get a is equal to 128 over x plus 2x squared. So at here we have a formula a in term of x. So now actually we can do the first derivative of a with respect to x. Then we will get negative 128 over x squared plus 4x. Okay, and then we have to solve the value by taking the first derivative is equal to 0. So we will get the x value as 3.17. Okay, the next step is that we need to identify whether the area is minimum or maximum. So we need to do the second derivative. So we get 256 over x cubed plus 4. So at x is equal to 3.17, we substitute into the second derivative. Then we will get 12.04, which is the positive value there. So we now know that the second derivative is greater than 0, that make the area is minimum. So when x is equal to 3.17, so we substitute back into the formula of y. y is equal to 32 over x squared. So we will now get y as 3.18. So this is dimension that we are looking for when the surface area is minimum. Example 2. Determine the maximum area of rectangular window with semicircular at both sides as shown in diagram below if the perimeter of the window is 30 feet. So now the question asks about what is the value of the maximum area if the perimeter given as 30 feet. So as shown in the diagram, we can see that there is a two semicircular shape and also a rectangular shape with the side length of L and also the diameter of a semicircular is 2r. Okay, now it's given P is equal to 30. Now we have to find the whole perimeter here. So we have two side of L. So it is L plus L, so we get 2L plus the arc length for semicircular, both are 2 pi r. Then the total perimeter is equal to 30. Then let's try to make it one term. So L is equal to 15 minus pi r. And now we have to identify what is the area for this formula. Okay, the area for a semicircular is given as pi r square over 2. Because it has two semicircular, then we plus another one. So actually we get 1 pi r square. And then for the area of the rectangle shape is actually L multiplied by 2R. So we get 2RL. So total area, surface area is actually pi r square plus 2RL. And then notice that we already make L is equal to 15 minus pi r. So substitute into A. So we will get pi r square plus 2R in bracket 15 minus pi r. So it's equal to 30R minus pi r square. So we have A in term of R. So now we need to take the derivative with respect to R. So we get 30 minus 2 pi R. Take the derivative equal to 0. So now we get R is equal to 50 over pi. So now we have to calculate the second derivative to know whether at this point is maximum or minimum. So we get negative 2 pi. So we know that this is less than 0, so it is maximum. So now we substitute R is equal to 15 over pi inside the A formula. So now we get the maximum area as 225 over pi feet square. Okay, now exercise 1. A manufacturing needs to make a rectangle that can be inscribed in a circle of radius 4 cm. Determine the dimension of the rectangle that will maximize the area in its construction. When the question asks about dimension, it means that we have to identify and calculate all the related variables involved in any of related formulas that we can consider as a function. So in this question, because it mentioned about a circle of radius 4 cm, so now we have to write the equation of a circle. So the equation of circle is given as x squared plus y squared is equal to r squared. So we know that r is equal to 4, substitute, then we get x squared y squared is equal to 16. And then we have to make this as one term. Y is equal to square root of 16 minus x squared. So we get y in term of x. Okay, next we have to find what is the area of rectangle. So by looking at the figure, we can see there is a coordinate of x, y at the edge of the rectangle inside the circle. So as we can see, let's say at the y-axis, we can see there is a arc length at the positive axis, but also there is another x length at the negative axis. So actually, the right side of the rectangle shape there is actually 2x. Same goes to y at the vertical shape, at the vertical line there. So at the positive we have y, and at the negative side also we get another y. So it's actually, the area is actually 2x multiplied by 2y. So A is equal to 4x, and then we substitute y, we get 4x square root of 16 minus x squared. And then we need to find the first derivative. Okay, by using product rules, you still remember, right? Okay, and then we take the first derivative is equal to 0. Solve x, then we get x is equal to 2.8284. At this point, we must know whether it's a maximum or minimum. So in this case, we need to find the second derivative. So the second derivative, by using the power rule and the product rule, so we get the x value less than 0, which means it is maximum when x is equal to 2.8284. Now, we just substitute back the x value inside the y function. So now we get y is equal to 2.8284. So now we have solved the dimension of the rectangle that will maximize the area. Okay guys, that's all for today. Now we have end our chapter 3. So let's check your comprehension.